Hi everyone, it's Yanis from WeTakeO, and welcome to the first podcast about connecting to the cloud. We'll go through a series of questions and subject around the cloud, and the subject of today is connecting devices to the cloud. And for that, I have Adrien and Fernando. They are two technical experts from WeTakeO. Guys, how are you?
Hey,
I'm
doing
doing
good.
great.
Nice. Here's the first step. I think is it's great to have a first introduction of ourselves, and then let's after that jump into the subject. Adrian first.
Sure. I'm working at Utekio as a software architect. So most of the time, that will be trying to understand the goal of the different companies we work with, what they want to achieve at a device level, how they want to connect, what their constraints are, and figuring out the right solution, the right technologies to use to do that in an optimal manner. So that's basically that, trying to design that whole solution and having fun doing it.
Nice. Yeah. And I'm Fernando. I am working as a cloud architect here at Witekio, which means I am helping to get all of those embedded devices to connect securely into tools like Amazon Web Services, Microsoft Azure, and helping build the solutions behind everything that interacts with the cloud.
Perfect. And I'm Yanis from WeTakeO, digital marketing officer, and we're hosting this podcast for you, for our community. Thank you guys for this introduction. Let's start first with this question: how do IoT devices authenticate to the cloud?
That's a great question. So there's actually, this is Fernando. There's actually a lot of different ways that we can do that. One of the most common and kind of most secure options that we typically see is something called X509 certificates, and those are certificates similar to what you would use if you're trying to SSH into a virtual machine, or similar sorts of certificates to what you might use if you're dealing with things like HTTPS, with some notable differences. But basically, the way those work is you have a public and a private key, and you can interact with those cryptographically to make sure that you're securing connections between the devices that prove that they're hosting their private key on the device, and then you can make the public key public so that people can go and look at that and then say, yes, I recognize that this device is who they say they are because they proved it to me. So it's kind of a really high level explanation of how that works. But there's also a lot of other methods. One of the other ones is called TPM attestation. There's also some less common methods with symmetric keys, which basically are just key values that you put both on a device and somewhere else to authenticate back and forth between that device and wherever it's communicating with. Usually that could be something like a public cloud. There's also less common methods like JSON Web Tokens, which you can create from your devices and interact similar to how you'd use them in a kind of web application scenario. But X509 certificates are definitely the most common. And usually, what we'll see there are two different kinds. Either you'll use a purchased root CA certificate, where you get from a public vendor that sells those sorts of certificates and interacts with the public key infrastructure of the internet, so that if you want to purchase a certificate that somebody else will recognize, you're able to do that. But you could also self-sign your own certificates and use your own root certificates. And then you can sign multiple certificates lower than that to eventually put them all on your own devices.
Okay, that's all clear. So why in that situation would you purchase a certificate? Like, what would be the advantage of using a purchase certificate versus one that you can self-sign, because you can do that?
Yeah, that's a good question. And obviously, if you're, paying money, you want to know what you're getting out of it. I think there's kind of two big benefits that you might get when you're purchasing it. But it really depends on if your devices need to interact with the larger internet. That's a kind of first question you might ask. Because purchase certificates are issued from publicly trusted vendors. The certificates that they issue are signed by their root certificates up a kind of chain of certificate signing, which means that they're likely going to be able to be trusted by other devices instead of just your public key infrastructure. So, for example, if I go to a website in my browser right now, my browser already trusts a lot of the root sign certificates from public CAs. And it's a kind of similar concept when you're working with your IoT devices, where if you're using a certificate that's signed that you've purchased from one of those CAs, there's a likelihood that you'll be able to use that with other devices or in other ways and have it be trusted because that root sign CA that you purchased goes all the way up to that public provider. Whereas if you're doing it by yourself, you can definitely make sure that your own infrastructure trusts your own devices with that self signed certificate, but you won't get all the same benefits that you get from purchasing it.
So we know that generating an X509 is going to be significantly more work than overall like generating or using a symmetric key, because a symmetric key is just like that string of characters that you can use and say, hey, this is my token, my key, and be done with it. So I guess one of the thing we can explain is why not using symmetric keys that are significantly simpler to use?
Yeah, that's a great question. And I think that comes up a lot. When we're working with symmetric keys, basically that means that we need to have them exist in multiple locations at the same time. So, in the case of IoT devices connecting to the cloud, they need to be stored both on the device and in the cloud. And either moving the keys between those two locations or having them stored in both locations can sometimes open up more attack surfaces because it's stored in multiple locations. And it also means when you're working with those keys, moving around between the two places can risk compromising them more. And so while Microsoft Azure actually supports using symmetric keys with IoT Hub and with its device provisioning service, one of the common things that they even say is that those keys can, with symmetric keys, can end up leading to bad development practices. For example, hard coding them in the source code and then inadvertently having source code be exposed or leaving them exposed on devices. If somebody can access one of your devices, can they review the code inside of the device and then find the symmetric key? And if they can do that, can they basically do anything they want in between the device and the cloud or the device and wherever else it's connecting with the symmetric key? So, for a few of those reasons, one, that it exposes a larger attack surface, and two, that it can kind of lead to worse development practices. Those are reasons why we usually only see symmetric keys in particular cases. And the kind of worst possibility there is that when you end up using symmetric keys in certain environments, you might even end up reusing the symmetric key across multiple devices, which is kind of the worst case scenario, because then someone can compromise a fleet of devices with just accessing one key on one device. And then you're really in for kind of a terrible security nightmare.
Right. And I guess so, because that symmetric key setup is so simple, it would still make sense, like you said, in some specific situation. And I can definitely say, for example, prototyping, when you just
Hmm.
want something simple and
Yep.
not having to deal with the root certs and
Yep.
everything.
Absolutely, yeah, and it's a great method, especially on Microsoft Azure, because they support that pretty well for symmetric keys. Not so much on Amazon Web Services; they don't really have built-in options for symmetric keys. But definitely, if you're just prototyping, with a device that's on your desk that's not going to the factory floor to get made into 1,000 devices, it's a great option to get up and running pretty quickly with IoT and connecting it to the cloud. But past that, I think that's when its kind of utility drops off, and you should be questioning whether or not you want that in your manufacturing workflow, or if it's a security risk. Maybe there's cases where devices have just so small of a memory footprint that'd be kind of up your alley, Adrien, to decide whether or not it needs a symmetric key instead of a certificate. But that's a very, very specialized case, I think.
Yeah, and even then, usually you can spare the few additional bytes, or more than a few bytes. You can usually spare that size. You have other options. I would definitely agree with you that symmetric keys are just for very specific uses. They present a risk, and it's simple, but that's the one upside that they haven't, the
Yeah.
one and only.
So there's, I think, another option that I mentioned earlier around TPMs, but that's an option I haven't worked with as much, and I don't know if you can go into that more, Adrien.
Yeah, so with a TPM, you have a module, so an IC that you put on your embedded device, that you can use to securely store keys or certificates, basically whatever you want to protect on your device. And these TPMs also have unique keys, so each has a unique one, that you can use as a unique identifier for your device, and register that in your cloud infrastructure. The advantage of using a TPM is that you're sure that whatever secret you have, and especially that identity and that key pair, will be stored securely, and it cannot be accessed at any point, because it will only live inside that TPM. And you have basically different specifications for TPM. The most recent ones are the 1.2 version 1.2 and 2.0 of the interface specification. And different vendors will sell you TPM that basically adhere to that interface specification. And this is supported both by the U-boot bootloader, that is the most common bootloader, I'd say, for Linux embedded devices, as well as in Linux with your in the Linux kernel directly through an existing driver in the mainline, and other OSs like Azure Sphere. So it's just an additional piece of hardware that you can use that will contain its own identity and allow you to securely store this identity, that key pair, and other information that you want to be available only on that device and not accessible.
Thank you, guys. We discussed about authentications, but my question right now is, how do you handle permissions and security?
Yeah. So when we're dealing with authentication, that's kind of the first step of figuring out the security story and the communication story between devices and the cloud. The authentication step is kind of me saying, "Hey, I'm Fernando," and then I show my driver's license to Adrien, and he's like, "Oh, yep, you're Fernando. That looks like a real driver's license. We're all clear there." That's the certificate story. There is that driver's license. Um, then the second part is authorization. So not authentication, but authorization. And the difference there is, even though I am Fernando and I am who I say I am, maybe I say, "Hey, I'm going to use Yanis's credit card to buy myself a nice bike or something." And
Definitely.
yeah, and you probably don't want me to be able to do that. So we'll set up some authorization so that I only have permissions to use my credit card. And that's the second step for those devices. They have the certification to prove that they're the devices that they say they are. But now we need to set up permissions so that they can only take the specific actions that we want them to be able to take on cloud services.
I had a quick question about that. So this permission, I know that it's easy to set them up manually per device or per service. How do you pre-configure those so that when you register a new device, it's already set up to be secure or to have the right permissions?
That's a good question. So, with those devices, there's a few different ways you can do it. As you said, there's a manual way. You can always get your certificate for a particular device, or your symmetric keys, or TPM attestation, however you're doing it. But basically, once those devices are in there, for different platforms, you'll need to set it up a little bit differently. For example, for AWS, you'll set up IoT policies, and those will usually apply to an IoT thing, which is the concept that AWS has for any devices that you're connecting into the cloud. And those policies can allow access to different AWS services. They can allow access to IoT topics inside of AWS IoT Core. So communicating with MQTT, sending messages to different topics like a registration topic, or maybe you're publishing messages that you need to get picked up by an application. So different things like that. Those IoT policies will take care of. But there's also a few other ways in AWS. So you could use AWS Identity and Access Management and Cognito, and those things would usually apply more to mobile devices and mobile applications that also have some sign-in component to them. But to do this automatically in AWS, you usually have a just-in-time registration or just-in-time provisioning setup where essentially you'd have a template that gets applied to any devices that are connecting through that provisioning process, and a set of permissions that will then be applied to those sorts of devices.
Okay, so yeah, so you can basically pre-configure it to have the right permission once and then be done with it for all the device that join after that.
Yep, exactly. And even within that, you can say, instead of giving blanket permissions to all those devices, you can actually have them be unique for each device, even though you've configured it once. So I could say, for example, Lightbulb 1 only has permissions to publish to Lightbulb 1's topic, whereas
Yeah.
Lightbulb 2 only has permissions to publish to Lightbulb 2, and they all share some permissions to publish to a registration topic or something. So yeah, it's pretty useful to be able to create those templates but still have them be unique. And it's pretty similar for Microsoft Azure. There's a few differences in how those permissions get applied to authorize specific actions, but you can create similar policies that will provision your machines there, or your devices there to have those permissions.
Right, and the Lightbulb 3 can access Yanis credit card. That's
Exactly.
the one.
Yeah. We'll make sure that
Yeah.
that happens in all of our policies, as long as it's Yanis' credit card.
Okay. So let's back up a step. How do we make sure our IoT device get the credential they need to connect to the cloud in the first place?
So we were talking this a little bit earlier, where we have single devices, where we either set up symmetric keys or we set up a certificate for them manually. We can definitely do that for individual devices, but once we get to scale and we're manufacturing our devices, maybe in a warehouse or a production line, we're going to want to take a different approach. Usually that looks like us registering our root CA cert with a cloud provider. So either AWS or Azure is what we've been talking about a lot in this case, but any provider we're using. And then we prove that we have the private key for that root cert that we're uploading the public key of into the cloud. And then that basically lets Azure or AWS say, okay, every time we see any other certificates that have been signed by this root CA's chain, let's go ahead and make sure we allow those in and allow the configuration profiles to be applied to them that you configure. And what that means usually is I take my master root certificate and I create these intermediary certificates that I give over to a manufacturing plant to sign the leaf certificates or the device certificates. And there might be multiple layers of intermediary certificates in between. So I might take my root certificate, give it to, manufacturing plant A, and they have their intermediary certificate that I have them use, but they have their technicians use technician intermediary certificate A, and then a technician intermediary certificate B, and etc. And then those might then sign every device that kind of goes through the plant that they're working on. But basically, that's how that full chain works, where every device will get a unique certificate, and then those devices will be able to connect to the cloud because we've configured the public key of the root CA in the cloud to trust anything signed by that root CA.
Right, and then there's also all the manufacturing side of it. So how do you make sure that all these devices can quickly, efficiently have this certificate provisioned? So how during the manufacturing you create that process that will automatically generate the certificate, store it securely on the device, share it with the cloud or not if it's not needed. So hopefully you don't need that with like the explanation, what you explained just previously with intermediate certificates. But there is that need also at a device level to think about how this provisioning is going to happen, and what you need during manufacturing to generate it and securely store it on the device, so that it can scale to a lot of units without requiring a lot of manual work every time. So this was like we just talked about the credentials, and also like I just briefly talked about how you get that in a device. But as we are focusing on more the cloud part, one big component of these IoT cloud architecture is what we call this device twin, which is also called shadow in AWS. And this is essentially a duplicate of your device state in the cloud, so that you can have services that query that directly, and you don't need to reach out to your device. You can just reach out to your cloud and get that information. So you have that copy of your device. But what I wanted to ask was, we have that copy in the cloud, but again, if you want to have a lot of device, you'll need to get an initial state of that when you register your device. How exactly would you do that?
Yeah. So when we have essentially the device twin or device shadows that we know our devices are going to need, we'll usually create some sort of template to help do that. Obviously, there's the manual provisioning option with any of the clouds where we can go and set up what the device twin, device shadow looks like for a particular device. But as we go through the process and do it with thousands and hundreds of thousands of devices, we don't want to do that. So with different clouds, there's different possibilities. AWS has two options usually that they'll suggest, even though there's a few others for the provisioning process that we could use. One of the main two are called just-in-time provisioning or just-in-time registration. And what those look like for just-in-time provisioning, it's a template that's applied to every device registration at its first connection. And that's every device that's associated with a particular CA certificate. So if I have a self-signed certificate or a purchased root certificate that I've registered with AWS, I can set up a template so that any leaf certificate, device certificate that comes in and says, hey, I'm a device, it's going to go through the process of getting a thing set up with a particular name. It's going to get a policy set up with particular permissions, might get a device state with a particular state initially set up for it. And then that process can also be customized a little bit more with an alternative, which is called just-in-time registration. In that case, we use a service called AWS Lambda, which runs some of our own custom code at the first registration and lets us set up very customized situations with any of our devices. So, if we want to register a device through MQTT, it publishes a, hey, I'm here, I'm trying to register. Then it'll go and set up anything customized we want for any of the devices and any of the fields that are coming in from that registration.
Right.
Yeah.
So when you have, so basically at the beginning, your device registers and you have that initial configuration that the device is going to be able to use for its initial configuration. Yeah.
Mm-hmm. Yeah, exactly. And for AWS and also for Azure, there's other ways to do it where you can have a trusted user, which might be like a field technician with something maybe like a mobile app or some other authentication mechanism that that makes sure that you can trust them. There's also things like claim certificates, which are alternatives when these other options aren't a good option. Basically, what those look like are longer lived certificates that you can use to get a unique certificate. So that's kind of a weird workaround for devices that you can't put a leaf certificate on initially, but you can put a claim certificate on. The claim certificate has really limited permissions and will only essentially allow getting a unique certificate without accessing anything else. But there is a little bit of risk there because if you expose your claim certificate, you kind of have a blast radius of all the devices that you've already shipped but are not yet activated, because
Right.
then anybody with a claim certificate can go and mimic them basically.
Yeah. So it's a quick, or it's a way of getting this device started, even if they don't have a
Mhm,
unique
mhm.
certificate. But obviously the downside is they don't have a unique certificate
Yep.
yet.
Exactly, exactly. And so you have those same risks there. And it's pretty similar with Microsoft Azure. In addition to AWS, you can go through that manual process, Or what Azure does is kind of like a bit of a change. Instead of having their own like kind of custom way that you're doing it, what they'll do is a little more streamlined. Well, they'll funnel you through something called the Azure Device Provisioning Service. And that service will really take care of the what's called the enrollment process, which is basically the same as AWS's just-in-time provisioning and just-in-time registration options, where you can set up individual enrollments with things like TPM and Symmetric Keys or X509 certificates, where you set up the way that you will provision, for example, the device twin or permissions on a device through those individual enrollments for each individual device. There are ways to automate that through the APIs and the CLI, but for those options, you can do the individual. Whereas for larger groups that'll have the exact same permissions, you'll do those for X509 CA certificates. So things like that, full root CA, intermediary CA, leaves device certificate CA, you can set those all up as having the same template essentially that will apply all the state of the device and other things kind of cascading down through all those devices.
Right. Cool.
That's true.
Well, it looks like it's really easy for you guys, but for me, like I barely understand what are you saying. But it feels like it's a ton of works. But once you have did this those parts, it makes your life easier. But I think I have a last question, if I may. But this manufacturing and provisioning process seems pretty complicated, like I said, and like a lot to manage. Are there any hardware or software tools that can help streamline this process for people?
Yeah, so there's a few. I mean, definitely depending on the situation where you have a customer coming in, sometimes to a Techio who already has their hardware picked out, that might be a situation where we just talk about what the options are if they already have kind of their specs for everything that they're building. Whereas if someone's starting from scratch and they reach out to us, what we can also talk about is what all the options are really. And one of those that's inside of Microsoft Azure that we've been looking at more recently is something called Azure Sphere. With that, you'll get essentially a device that's already kind of pre-enabled with Microsoft Azure. Basically, the way it works is Microsoft partners with a bunch of silicon vendors who create devices that do all of the really annoying pieces of dealing with all the credentials and the setup and the connection between Microsoft Azure and the device, and they kind of do a lot of that for you already. Basically, it'll help you manage some of the security and the updates to those devices and pushing out changes to the application. And all you have to do to get started with those inside of the cloud is to do something called claiming the devices. And that basically just says, hey, I want this device, this physical device that I'm working with here, to be tied to my company or my organization. And then you get all the security that they kind of bake into that whole process. I don't know, Adrien, have you worked with those before? Have you gotten any other insights from those devices too?
Yeah, so Sphere devices are definitely a great way to just make things easier, and it's still pretty young. So we'll see how that evolves. Right now, there's only a very limited set of hardware that are supported instead of modules, but it definitely makes it a lot easier. Another way to make it easier is to use some specific secure element, which is a dedicated chip that you'll have on your device, like we talked a bit about the TPMs before. And these can be pre-provisioned with keys that are already authorized in your architecture. You can basically work with partners, manufacturers that will just give you this IC that is already set up to have the right keys and everything to be enabled for your cloud architecture. So they just give you that IC, and that IC has the right certificate. The certificate is provisioned in your cloud architecture, and you just need to solder it onto your board and not worry about all the manufacturing process and all that.
And
So
for
that's, for
those,
example, another way to make all of this less complicated as well as more secure, because you
Mhm.
don't need to deal with the certificate generation yourself. You can basically have another company do that, and usually they'll make sure that all this whole process is very secure, and that whatever certificate, intermediate certificate you're using, is never leaked, of course, and only used for that specific chip that will be used for you.
Thank you, guys, both of you, for this first amazing podcast about cloud. Thank you because you have replied to all the questions with that much details. Uh, Thank you for those who join us on the social networks. We take your social networks after listening this podcast. You can follow us on LinkedIn, Twitter, YouTube, and Facebook as well. We'll see you again next time for the episode number 2 of this podcast series about cloud. Thank you, Fernando, again. Thank you, Adrien, again.
Yeah, thank you.
And see you
Yeah.
soon.